Hi, I'm Cem Küçük. I carried out this project with my dear friends Oğuzhan Yorulmaz, Murat Vedat Yurttaş from Civil Engineering, and Özge Zorlu, Dilem Ergün from Physics Engineering. Our project is interdisciplinary project and it consists of two parts. Firstly, as a civil engineers, we determine level of service at Hacettepe University Sığıya campus. So, we determine road quality. And also, we observed some problems associated with traffic. After that, we took exhaust gas samples for second part of our project. Exhaust gas pollution has an important effect on human health, and it can be more critical importance for hospital regions. So in the second part, we observed the samples in the laboratory. Furthermore, we compared the protection of different types of masks.
Firstly, we determined which road we will study on. It was the road in front of Hacettepe Children's Hospital. We measured properties of the road. Our first objective was determining the level of service of the road. We counted the passing vehicles 3 times an hour for 15 minutes intervals. We counted the vehicles on Friday, Saturday and Monday when the vehicle density is highest during rush hours. We started counting vehicles at 7 a.m. and finished at 7 p.m. While counting, we took note of the temperature of the air in that time interval. The average temperature was between 6 and 7 degrees Celsius. Our second task was how much pollution the vehicles released into the air. We attached a face mask in a vacuum cleaner and used it on rush hours.
We counted the cars passing through the roads we numbered. After that, we calculated LOS by using calculation sheets for each road, where A is the best condition and F is the worst. We saw that LOS was level F during the rush hours on Friday and Monday. There was barely any traffic on Saturday. Although there are no problems with the quality of the pavement, the main reason of the problem is because the one-lane roads cannot take the load of the traffic. The other problem is the stopping of the vehicles. When one car stops, the traffic behind also stops, causing a traffic jam. To solve these problems, the width of the road can be expanded, and extra pockets could be constructed to lighten the traffic. If these measures are not taken, air pollution will affect more and more patients. In the second part, we examined air pollution caused by the traffic jam on different masks.
Particulate matter is classified as PM2.5 and PM10 by particle size referring to PM, whose particle size is below 2.5 and 10 micrometer respectively. PM2.5, which has small particle size, can penetrate the bronch and lungs and poses a serious health threat to the public. We carried out this work on vehicles. While doing the study, we use surgical masks, which are very preferred today as filters. We took measurements from 3 different cars and services with 5 different masks. With a mask, we also took measurements from different distance from 3 different cars. The 5th one was first case designed by using spider silk cocoon weaved by Argiope Lobata. We used SOx analyzers to determine nanoscopic particle size.
Measurements from 5 different filters show that particle size vary between 15.7 and 45.7 nanometer. The filter that holds smallest particle has been found the spider membrane. This filter held particles of 15.7 nanometer in size. Measurements at different distance revealed that smaller particles were retained as the distance became shorter. The particle size ranged from 17 and 28 nanometer. The size of the particles in the measurements made with services varies between 20.2 and 28.3 nanometer. As a result, surgical masks can hold particles ranging in size from 15.7 and 45.7 nanometer. It was understood that these masks were in fact able to greatly prevent the inhalation of polluted air. This study was conducted prior to the pandemic period. The size of the bacteria and viruses varies in the range of the 40 and 3000 nanometer. Therefore, these surgical masks can also be used to protect against bacteria and viruses.